Hello students, let us continue the session on probability. In the previous session, we had discussed the concepts related to probability, and also we have solved 5 questions. Let us continue from question 6 onwards. Question number 6 is, a bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange colored candy? Second, a lemon flavored candy. You must understand the question. Bag contains lemon flavored candies only. It means that if she is taking out a candy, it has to be a lemon flavored only. So it cannot be orange flavored. Therefore, the probability of picking up an orange flavored candy will be 0. It's an impossible event. So let me mention the answer in this way. Since bag contains only lemon flavored candies, the probability of taking out an orange flavored candy will be 0. It's clearly an impossible event. In the second, you can see she has to pick up a lemon flavored candy. Since all the candies which are present in the bag are lemon flavored, so the probability of picking up a lemon flavored candy will be 1. Since bag has only lemon flavored candies, probability of taking out a lemon flavored candy will be 1. So in the first case, we have impossible event. In the second case, it is a sure event or a certain event. Question number 7. It is given that in a group of 3 students, probability of 2 students not having same birthday is 0.992. What is the probability that the 2 students have the same birthday? It is like the combination of the events which are possible or not possible. Here, the probability that 2 students are not having same birthday is probability of not an event. This is 0.992 as it is given in the question. Therefore, the probability of two students having same birthday will be probability of event, which is 1 minus probability of not an event. Is it like complementary one? So 1 minus 0.992 we have to do. So we get it as 0.008. So the probability of two students having same birthday will be 0.008. Question number 8. A bag contains 3 red balls, 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is first one red, second one not red? Here, the total number of balls in the bag is 3 plus 5, which is 8. Therefore, the probability of getting red ball will be the number of favorable outcomes out of the total number of possible outcomes. It's very clear that there are only 3 red colored balls. So 3 upon 8 will be the probability of getting a red colored balls. In the second, they have asked the probability of getting or drawing a ball which is not red. It is a complementary event. The probability of not getting red balls will be equal to 1 minus the probability of getting red ball. This will be 1 minus 3 upon 8, which is 5 by 8. Question 9. A box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be a red one or a white one, not green? Here you must first find out the total number of marbles in the box. So the total number of marbles will be equal to, there are 5 red, 8 white and 4 green, and it is 17. First question is to find out the probability of getting red marble. Here we need to find out the number of favorable outcomes upon the total number of possible outcomes. There are exactly 5 red marbles out of 17, so the probability is 5 by 17. In the second, we need to find out the probability of getting a white marble will be equal to There are totally 8 white marbles out of 17, so it is 8 by 17. Here, for the third one, let me first find out the number of green marbles. The number of green marbles are 4, so the probability of getting green marble will be 4 out of 17. Therefore, the probability of not getting a green marble will be equal to 1 minus 4 by 17, and this will be 13 upon 17. Question number 10. A piggy bank contains 100 50 paise coins, 50 rupees 1 coins, 20 rupees 2 coins, and 10 rupees 5 coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin and will not be rupees 5 coins? Here, the total number of coins in the piggy bank we need to find. Here, the total number of coins in a piggy bank. Let's find this out. This will be, there are totally 100 50 paise, 51 rupee, 22 rupees, 10 5 rupees coin, and the total is 180 coins. The first question here is to find out the number of probability of getting 50 paise coin. So for that, the number of 50 paise coin will be 100. Therefore, the probability of getting a 50 paise coins will be equal to the total number of favorable outcomes by the number of total possible outcomes. This will be equal to 5 by 9. Second one, let's first find out the number of rupees 5 coins. Here the rupees 5 coins are 10 in number, so the probability of getting a rupees 5 coins will be 10 out of 180, which is 1 by 18. Now I can find out by the complementary events probability of not getting a rupees 5 coins will be equal to 1 minus 1 upon 18. We get it as 17 upon 18. Question number 11. Gopi buys a fish from a shop from his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish, 8 female fish. What is the probability that the fish taken is male fish? Here the total number of fishes in a tank is the number of male fishes plus the number of female fishes, and it's 5 plus 8 and the total is 13. Here the probability of getting a male fish will be equal to either 5 favorable outcomes out of the total possible outcomes at 13. So 5 by 13 is the required probability. Question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4 till 8, and these are equally likely outcomes. What is the probability that it will point at 8? Second one, an odd number. Third one, a number greater than 2. Fourth one, a number less than 2. Here the total possible outcomes are 8. The total possible outcomes are 8. First question here is the probability of getting 8. There is only one possibility out of the total 8 outcomes, so 1 by 8 is the probability. For the second one, we need to identify how many odd numbers are there. Here the odd numbers are 1, 3, 5 and 7. Totally 4 odd numbers are there. So the probability of getting odd number will be 4 out of 8, which is 1 upon 2. In the third, we need to identify the number greater than 2. Let's identify 3, 4, 5, 6, 7 and 8. Totally there are 6 outcomes which are greater than 2. So the probability of getting a number greater than 2 will be equal to 6 out of 8, which is 3 by 4. In the fourth, we have to identify a number less than 9. Here all the numbers are less than 9. So the probability of getting a number less than 8 will be 8 upon 8, which is 1. Question number 13. A die is thrown once. Find the probability of getting a prime number, a number lying between 2 and 6. Total odd numbers. Here the possible outcomes are 1, 2, 3, 4, 5 and 6. So there are totally 6 possible outcomes. First one is to find the probability of getting a prime number. Let's identify what are the prime numbers. So the prime numbers on a dice are 2, 3 and 5. So there are totally 3 prime numbers. So the probability of getting prime number will be 3 out of 6, which is 1 upon 2. In the second, we need to identify the number lying between 2 and 6. They are 3, 4, 5. So the probability of getting a number lying between 2 and 6 will be equal to 3 out of 6, again 1 by 2. Now I need to identify odd numbers. So what are the odd numbers on a dice? Odd numbers are 1, 3 and 5. So the probability of getting a odd number will be equal to 3 out of 6. Again it is 1 by 2. Question number 14. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. You need to know that there will be 2 kings of red color. Therefore, the probability will be 2 by 52, which is 1 upon 26. So let me mention that probability of getting a king of red color will be 2 by 56, which is 2 by 52, 2 by 52, which is 1 upon 26. Second, face card. You must know that there will be 12 face cards. So the probability of getting a face card will be 12 upon 52, which is 3 by 13. Third one, a red face card. There will be 6 red face cards. So probability of getting a red face card will be 6 upon 52, which is 3 by 26. Fourth one, the Jack of Hearts. There will be only one Jack of Hearts, so the probability of getting the Jack of Hearts will be 1 upon 52. Probability of getting a spade. Totally there will be 13 cards which are spade, so 13 upon 52, which is 1 by 4. The sixth one, probability of getting the Queen of Diamonds will be 1 upon 52. You must remember the type of cards which are present in the deck of cards. There will be 4 sets of 13 cards. In those, there are few cards which are numbered cards and few are face cards. There will be 3 face cards, and these 3 face cards in one set. Totally 4 sets. So 4 multiplied to 3, there will be 12 face cards. Out of these 12 face cards, 6 of them will be a red color and 6 of them will be black color. Question number 16. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at the pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Here we need to identify the total number of pens. So the total number of pens will be equal to, there are 12 defective is combined with 132 good ones. The total 144 pens are present. So the total number of good pens, they are 132. So the probability of getting a good pen will be 132 out of 144 can be further simplified. It becomes 11 by 12 because it is exactly divisible by 12. 12 11 times is 132. 12 times is 144. Question 17. A lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from this lot. What is the probability that this bulb is a defective one? Second sub-question, suppose that bulb drawn in case 1 is not defective and it is not replaced. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not a defective one? So let's solve. Here the total number of bulbs are 20. The total number of defective bulbs will be 4. Therefore, the probability of getting a defective bulb will be equal to 4 by 20, which is 1 upon 5. Second, we need to identify the remaining number of bulbs. Here the remaining number of bulbs are 19 because 1 is taken out. Therefore, remaining total number of non-defective bulbs will be equal to 16 minus 1, it is 15. Hence, the probability of getting a non-defective or not a defective bulb will be equal to 15 of 19. Question number 18. A box contains 90 discs which are numbered 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number, a perfect square, and a number divisible by 5. Let's solve one by one. Let us identify the total number of 2-digit numbers. Total number of 2-digit numbers between 1 to 90 will be, there will be 9 1-digit numbers, so 81 will be the 2-digit numbers. Therefore, the probability of getting a 2-digit number will be 81 upon 90. It becomes 9 by 10. Second, we need to identify the perfect squares. So the perfect squares between 1 to 90 will be 1, 4, 9, 16, 25, 36, 49, 64 and 81. Therefore, the probability of getting perfect square between 1 to 90 will be 9. Therefore, 9 out of 90, which is 1 upon 10. Now the third one, we need to identify a number divisible by 5. They are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, and 90. So the probability of this particular event will be 18 out of 90, which is 1 by 5. Question 19. A child has a die whose 6 faces show the letters as given below: A, B, C, D, E, A. The die is thrown once. What is the probability of getting A? Here, the total number of possible outcomes are 6. And there are 2 A's, so the probability of getting A will be 2 upon 6, which is 1 by 3. Getting D, there is only one D, so 1 upon 6 will be the probability. Question 20. There's a star mark here. This seems to be important question. Suppose you drop a die at random on a rectangular region shown in the figure. What is the probability that it will land inside a circle with a diameter 1 meter? Here they have given the dimension of this rectangle, so I can find out area of rectangle. So area of rectangle is 2 multiplied to 3, it is 6 square meters. Area of circle is pi r square. Since the radius is 1, since the diameter is 1, radius will be half, so it is pi times 1 by 2 whole square, which is pi by 4. Therefore, the probability of die will land inside the circle is pi upon 4 divided by 6, which is pi by 24. This is related to geometrical probability. Question number 21. A lot consists of 144 ball pens, of which 20 are defective and the remaining are good ones. Noori will buy a pen if it's good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives to her. What is the probability that she will buy it? What is the probability that she will not buy it? Here you must understand that total number of pens are 144, out of which the total number of defective ones are 20. So the good pens will be 144 minus 20, which is 124. If it is good one she will buy, so the probability of getting a good pen will be 124 upon 144 can be simplified, becomes 31 upon 36. Probability of Noori will not buy a pen will be 1 minus 31 by 36, which is 5 by 36. There are 5 more questions which are little lengthier one we shall take up in the next session. That's all for today's session. Thank you.